Okay, so we've got a question here, and it's for theta is in the range of minus 180 to positive 180 inclusive. We need to solve for theta in this function here. 5 sine 2 theta equals 9 times tangent theta. And then we've got a question later, find the smallest solution to 5 times sine of 2x minus 50 equals 9 tan x minus 25. But we'll come to that one later. So 5 times sine 2 theta, 9 tan theta. Well, we can see the theta is in the single angle formula, but the sine is in the double angle formula. So we've got a little bit of a problem already. So to solve that, we've got the double angle formula for sine. So what we do know is that sine of 2 theta is equal to 2 sine theta cosine theta. So that's the double angle formula. Okay, so if we just substitute that into there, let's see where that takes us. So now we've got 5 times 2 sine theta cosine theta, and that's still equal to 9 tan theta. Okay, well, we can change that 5 times 2 for a 10, that's fine. But here we still got sine, cosine and tangent. But we know that tangent theta is equal to sine theta over cosine theta. And then we've got everything into the single angles and sine and cosine. So let's put that in there and tidy up this 5 times 2. So that's another identity. So now that leads us on to 10 times sine theta cosine theta equals 9 sine theta cosine theta. Okay, so we've got sine thetas in the numerators because we could effectively put a 1 here if we like, and a cosine theta in the top and the denominator here. So we could divide both sides by sine. So let's try that. So that will then lead us, so let's just divide this by sine theta and take this and divide by sine theta. So now what we see, the sine thetas will cancel out and we'll have 10 cosine theta. That's looking a lot easier. And now the sine theta and sine theta will cancel out. So now we've got 9 over cosine theta. Okay, so now we're getting somewhere. We've got cosine theta on both sides and a couple of constants here. So to get rid of this denominator now will be the next phase. What we'll go for is to multiply both sides by cosine theta. So now if we take that and multiply by cosine theta, we now get 10 cosine squared theta. Multiplying this by cosine theta, we'll get cosine squared, and then this will have the effect of cancelling out this cosine theta. So that equals 9. Okay, so what leaves us to do now is to divide this side by 10. So that leads us to cosine squared theta equals 9 over 10. Okay, now we can just take the square root on both sides. So that will lead us to cosine theta equals square root of 9 over 10. That square root involves the 10 as well. Okay, so let's just have a look what we got here now. Now the cosine theta equals square root of 9 over 10. We've actually got plus or minus square root of 9 over 10. Okay, so now let's just draw the cosine graph and see what we can achieve with that. So we'd have plus 1 up here, minus 1 here. Here we'd have 360, 180, 90, 270, same here, minus 180, minus 90, minus 270, and minus 360. Okay, so the cosine graph has period of pi, so at 0 it's 1, and at 360 it will be 1, but at 180 it will be minus 1. So we'll follow this kind of trajectory, something like this, and then go off forever. And same here, it will come down, go through the 90, hit the bottom at 180, and again reach plus 1 at minus 360. So cosine theta equals square root of 9 over 10. That is almost 1. So therefore, theta equals arc cosine of square root of 9 over 10. We could write 0.9 there if we wish, make things a little bit easier. So therefore, this theta value is going to be somewhere here, here. If you draw a line across just below the 1, there'll be 1 here and 1 here. It's going to be just before here, just before here, like this. Okay, so now we've also got the minus version of this. So the minus version, it will hit somewhere along here. So just above the minus 1. So we've got 1 here, 1 here, 1 here, and 1 here. Okay, now we want the range to be minus 180 to plus 180. So we're only interested in the marks this side, so within this bit. So we've got 1 there, 1 there, 1 there, 1 there. So therefore theta, if you plug their values into the calculator, which I've just done here, we get plus or minus 18.4 degrees, which is where these two will be. And we also get plus or minus 161.6 degrees. So that's these ones here. So I'm going to write this one here, 161.6 minus 161.6, 18.4 and minus 18.4. So that's our solutions for theta. So there are basically 4 solutions. So that's the answer for our theta here. Okay, so to solve this one here, the smallest solution to 5 sine 2x minus 50 equals 9 tan x minus 25. All we're looking for here is to find x minus 25 minus one of these solutions gives us the smallest possible answer. So if you take x minus 25 and let that equal 18.4, that's quite a small one. What would x equal here? So what subtracted from x to be minus 25 gives us 18.4? Well, there x would be 43.4. Okay, that seems a little high. Let's try it another one. So this time let's try x minus 25 equals minus 18.4. Now we can see that the 161.6 is not going to cut it, so they're not going to use that. So what does x have to equal here? To be x minus 25, so x equals minus 18.4 plus 25, which equals 6.6. So that's going to be our smallest solution for x in this situation here. Okay.